Hello guys, this is Dr. Surasingha again with the continuation of our cemetery lab. Um, so what you have done by this time, right, is actually you have developed a hypothesis, right, and you wrote introduction and methods. I have provided feedback for those. Most of you actually got it right. There is generally in our both sections altogether, which is over 40 students, we have most of them, I think at least about after 40, more than 30, 35 at least, getting the job right. A few of you did not, and I provided feedback to you guys, and essentially all the feedback you require how to do it was provided in your lab manual. And now this particular assignment is a follow-up, the next step after you wrote the introduction and methods part where you have hypothesis in it, and then you already separately posted hypothesis via Blackboard discussion groups. Now that is kind of a um, not a different activity, it's a smaller part of the bigger activity you have already performed, right? And by this stage you should be done all of those, right? So by the 13th of October is the week that you are supposed to start posting your hypothesis in Blackboard. That's not hard because you are simply copying and pasting your hypothesis from the intro methods you already wrote and just posting it in Blackboard as an open forum, right? So you need to get that done by the end of the week of 13th. Now and then by October, I'm looking at my calendar over here just to make sure I don't mix up the rate now. By October 27th, right, what is due, what you require to submit. Let me take it out over here, right? So just reminding you of what is due, right? October 13th, by end of October 13th, week of October 13th, you are posting your hypothesis on Blackboard, which should not be that difficult. It's straightforward from your already written intro methods part, right? And most of you have gotten it right. A few of you did not. So if you don't, you know that by now. Just go back and look at Blackboard comments I have received. And then October 20th is actually the week of October 20th. You have time to go and collect data from cemeteries. And now I understand actually through office hours and through email, many of you mentioned that you already have collected data, which is great, right? You're actually ahead of yourself. Pretty great. Week of October 27th is actually the week that we are going to start today, right? We are going to start analyzing our data, plotting survivorship graphs, and trying to interpret those graphs and test whether we can accept our biological hypothesis or reject the biological hypothesis. So that's kind of the job we do on the week of 27th, right? So the assignment that starts on October 27th is due the week after, right? On November 3rd. Okay, now again, what is due on October 27th, right, is the data you collected from doing the cemetery lab, right? So what you do is, I have already provided a blank Excel sheet on Blackboard. You fill in that that sheet and upload it, right? I have provided separate instructions on that part already in a previous lab video. So now let's go into talking about how to analyze this data, right, that you already have in front of you, right? And this again, I'm using exactly the same Excel sheet that I gave you earlier to enter data and to submit them, right? So if you look at here, I have actually kind of plotted some fake data. This is not real data, right? I mean, this is a demonstration, so it does not matter whether I use real data or not. So what I'm going to do is I'm going to do a demonstration on how to do the plotting. Okay, so I go over here, insert, and and then I want to keep my actual cursor somewhere outside, because I am first going to make an empty chart. So if you hover around this particular point, it says insert line or area chart. I think it might be easy if I zoom in a little bit more to the data, and I go insert, right, insert, and then go to this chart section. In the chart section, I hit this particular one called insert line or area chart. You click it, and then you click this particular option which says line graphs. Okay, it's very simple line graph you need, and don't panic, you are going to get this empty graph. That's fine, because I did not specify any data, so you are going to get an empty graph. And remember, you should too. Okay, now what you have to do is you have to add data into that empty chart area. So you do this I always forget left and right. Right click, right, clicking the mouse button to your right where the mouse appears, this menu appears, and then you select data, right, that particular option. Now you need to add data to this, right? So you click add, right? So series name. So what does this data set want to be called? So I'm actually testing the first hypothesis, where we are interested in comparing the historical data, historical population versus the modern population. So I want to call my historical name, the series name, historic cohort. You can either type it right here in English, or you can actually reference the cell that says historic cohort by just clicking on it, right? And next you move your cursor to the level below. It says series values, and bring your cursor to series values. Now that is actually where you have to insert real values that you need to plot on your y-axis, right? So where is your y-axis? Your y-axis is actually this, right? Mortality rate. That's what you are interested in plotting, right? So all the other columns you created are not going to be plotted. You are only interested in plotting mortality versus age classes, right? That's actually one form of survivorship curves, right? So you're going to ignore all of these columns and just select this particular column, right? Just the data, right? And you hit OK, and still you're not done. So you have a y-axis, okay, but you do not have a correct x-axis. Your x-axis is actually called the horizontal or categorical axis. So you, in that particular section, you hit edit. What you do now is actually select the age group, which is the categorical data that will represent your x-axis. So I'm going to select all of those age classes and click OK. And click OK in this window, and look at this, right? It actually plotted. And if you actually kind of stretch the graph, it actually all the labels properly aligns, right? Otherwise there will be kind of a jittering happening on this end, right? So do resize it so it looks better. Now there are several formattings that we need to go through, but before doing any formatting, I need to, in order to compare the historic population with the modern population, I need to add the second population, the modern cohort, into that. So what I do, again, click on the graph you just created, again, right click, select data, the same option you went by, right? And then what you need to do is you need to add another data set. So you click add. So again, series name, you want to either type it directly as recent cohort or the modern cohort. In my case, I'm just going to reference to that particular cell by clicking on that cell, and then bring your cursor back to the second entry point, series values. And what you have to do over there is again select the data corresponding to the y-axis, which is the mortality rate of that particular age classes. So I'm going to select the same set of the same column like I did previously, and hit OK. And now you can see clearly and you can click here again. Now you don't have to worry about if you go back to that particular window. You already have, right? For the modern cohort, you actually are automatically plotting on the top of the x-axis for historic cohort, right? Your age classes are not different, so you don't have to reassign age classes, right? All you have had to do was reassign the values corresponding to y-axis, because x-axis does not change. Now if you look at the graph, that is actually should look much better in your end because you are plotting correct data. The orange one corresponds to the modern cohort. Look at the table and how the correct data set highlights, and now look at again the historic cohort and see how it actually correctly highlights what data set that you're looking at. So this is a way to proofread whether you're doing the correct job, right? This is very easy to follow that back up in Excel. Well, now we can worry about making your graph pretty, right? I need axis titles, right? I want to first put a title for my y-axis. So what I do is I go to chart design, first select the graph, select that particular element you want to format, and then chart elements, and then go to axis titles. We are right now interested in that y-axis, which is called the primary vertical, right? Kind of makes sense, it's a vertical axis. So you delete whatever they are by default, and then you type the corresponding name. Well, I'm going to put mortality rate, right? That's what it is. And in fact, I can also even include like the short acronym for that, which is LX, right? And I'm done with that. Then I select my categorical x-axis, chart elements, right? Remember, chart design, chart elements, again axis titles, go to primary horizontal axis, right? And then again delete whatever they are by default. And in certain version of Excel, when you start typing something, the default name disappears. What do I want to call this? I want to call this age groups or age classes. Doesn't matter what you call it. Well, does matter what you call it, but I'm going to call it age classes. Well, I'm still not very 100% satisfied about the axis formatting and the graph area. I would like to have kind of lines like outlining my entire graph area. So I am going to right click again, format plot area, right? And then I want to format my border, right? And I want a solid line, right? And I want that solid line to be black. And let's see what it happens. Yep. Actually, if you close that out, you can see, yes, it did, right? So still I need to format my categorical axis again. So I right click on the axis, right? Again, now I want to format, right? Not select data, format axis. And this thing pops up right now. On that one, what do you have to select? You need to go to this particular option with this bucket icon, which says fill and line. You click that, and then you go to line options. Under line options, you need a solid line and you want it to be black. And look at that. That's also done. And then what you have to do is, still I don't like in the way the axis formats. I want to see like kind of tick marks coming off my actual x-axis, right? So how do I do that? How do I get little tick marks on over here, right? So that I know where exactly my data points are. Well, again, click on the graph, right click on the axis, go to format axis, right? And now select this, the last option says axis options. Navigate all the way to this part saying tick marks. Open that drop down, right? And say you don't need minor tick marks because it's a discrete data set. So for major tick marks, say you need marks outside, right? If you go inside, see what happens. Like that's not something I like. It's hard to read, so I want to have it outside. And you will have the option of doing that, which may be better for Some people might like it, but I personally prefer having a cleaner interior graph and having my tick marks outside like that. I can do the same thing over here, right? For the modality rate, right? Again, you go to axis option, the axis options, and which is already open, and all you have to do is navigate to tick marks, major ticks outside, right? I prefer it outside, and in this case, if you want to, you can even have minor ones, right? And in that way, you can maybe easily read it. So you're actually almost done. What we are missing is actually we do not define what these two graphs are. You know that, I know that, but whoever reading it does not. So you need to add a legend. So you go to chart design, click add chart elements, right? And then take or move on to legend, right? And also to think about the legend position. There it provides so many options to put legends. Usually we don't do this one, like not on the left side. It's not not scientifically accepted. On the top is also not very a scientific standard. Bottom is fine, right? That's actually appears in scientific literature. On the right is also fine, right? And I'll go to the bottom, and since actually I have space, right? I have plenty of space in the graph. You also have the option of moving it onto the graph like this, and keeping it away from the rest of the parts, right? There you go. And in that case, if you can also resize the graph a little bit as well. Now, if you look at this graph, you can actually try to start interpreting it, right? So the blue line, historic cohort, orange line, modern cohort, right? So now looking at it, you clearly see that except when it hits the old age classes beyond, like, 80 years and older, right? Clearly there's a survivorship difference, right? Mortality differences between the historic and the modern cohort. You can say that mortality is much lower in the modern cohort, much higher in the historic cohort, consistently until the age of 80, right? After age of 80 seems like they actually overlap. Now remember, I am interpreting a fake data set, right? So you should interpret your data based on how your graphs behave, right? It would be really interesting if this completely flips, right? If your historic modern data is above the historic data, well, then of course you have a different trend. So the idea here is not to imitate what I am saying, but to understand how I interpret it. I'm looking at my graph closely, right? I'm looking at my younger age classes right over here, right? Let me actually enlarge it. All the way up to age 80, right? I have very clear differences in survivorship, right? Throughout that particular younger age class, very early age classes, younger age classes, middle age classes, right? All the way up to age of 80, right? My historical cohort consistently underperform my modern cohort in terms of survivorship, right? In other words, in terms of mortality rate of the historic cohort is consistently greater than the mortality of the modern cohort up until age of 80. And after age of 80, I do not see any significant differences between their mortality, right? Now you might ask the question, wait, professor, we are not having any error bars over here. How do we know it's significantly different? Well, understand this. You only have single population, single cohort for historic, single cohort for modern, right? In order to provide error bars, you need to actually go to multiple cemeteries for historical data in the same town, multiple cemeteries for the modern cohort in the same town or in the same area, right? So when you have multiple data points, you can actually create multiple graphs and then average those graphs and calculate an average survivorship for each cohort. Right now, we don't have that average per age class survivorship values, nor we have a data dispersion to calculate the standard deviation. So do not worry about not having those error bars. In this instant, since we have lot of data, we have 100 data points, right? So that is reasonably large enough not to use error bars. Okay, so if you think where are error bars, shouldn't we have them, shouldn't we sample more, you are right, but for the simplicity we are not going that way. So do use the word significantly even though you are not creating confident intervals. So bottom line, you understand how to interpret it, right? So now you connect back to your original hypothesis, right? Now, if my original hypothesis were that my historic cohort have greater mortality than my modern cohort, I actually support, my data support the biological hypothesis, right? And then actually I can bring back different examples. Remember in the introduction, you provide some very short rationale in support of your hypothesis, right? Now you can elaborate on these things, right? You can actually specifically talk about your area, and you can actually, since this is your hometown, you might know a lot about the history of your hometown. What are the reasons behind this increased mortality and on the modern day increased survivorship? Let me talk about that a little bit more in my next part of the lecture, lab lecture. But over here, I wanted to show you how to briefly interpret the graph, and then we will go into detail later. Now remember, you have two hypotheses, so follow exactly the same pathway and create another create a graph for your second hypothesis, right? And what I'm going to do is, just to make things easy for you, I'm going to provide you the exactly same data sheet, right, with emptied columns, right, so that you can actually populate them yourself and do your work. But remember, like, you will have to do it yourself for your second hypothesis. That should not be hard, right? And basically, up to graphing level, my demonstration ends here. Have fun, right?